So this is 3, 5, it's Friday, and I want us to go back and look at number 5 and proving that angle. And I have not even looked at this proof, and I probably can't do it cold, but I'm going to do my best. So we got it set up that we could solve for FT2 if only we knew what theta was. Well, we're going to go back to our x-axis, and that's where we had this. So I'm going to copy this, bring it forward. Oh, I did that. Okay. All right, so on the x-axis, we can prove to ourselves that 2 cosine theta 1 is equal to cosine theta 2. Are we good with this so far? So what if we divided both sides by 2? Just playing around. I think I'm starting to remember how this goes. So we'd get cosine theta 1 equals 1/2 cosine theta 2. Now, in any triangle, so if we call this theta 1 and this theta 2, then this is our 90. I'm blind stumbling my way through this. So it's going to be an analytical geometry issue. We're looking for a relationship between 90 and one of those angles because we want to get this down to like tangent equals. So we need to have sine divided by cosine. So if we divide both sides by cosine theta 2, can we put this in terms of theta 2? Oh wait, cosine of theta 1 is the opposite divided by the hypotenuse. Let's call this side A, B, and C. So cosine theta, oh my god, 2 thetas. Cosine theta 1 is equal to B divided by C, right? Adjacent divided by hypotenuse. And the sine of theta 2, lo and behold, is equal to B divided by C. Oh, holy crap. I actually kind of can't believe I did that.
Okay, sine over cosine.
Sine over cosine, so this is now sine theta 2, so this is tangent theta 2 equals 1/2. We can solve that. So inverse tangent 0.5. And it is not 60, but it's real close. Go ahead, do it.
Wait, how did you turn the...
I got 26.5.
You got 36 point something? Or 26. Yeah, it's like 26 and 64.
How did the cosine turn to sine?
Because the cosine of theta 1 is equal to the sine of theta 2.
Oh, okay, we changed it.
And I changed it. Yeah, I should have included that step. I'm sorry. That was not.
You probably said it, but...
I did, but I didn't write it down, and that's bad form.
It really makes sense.
It makes perfect sense, but it's really hard to get there on your own.
Yeah. That's gonna be, yeah, correct. So the inverse tan of 1/2.
Inverse tan of 1/2 gives you one of your angles. And if you've got one of your angles, you can figure out the other one.
What was the...
So therefore, sine theta 2 equals cosine theta 1. There. So what's theta 2? 26? 26.5, blah, 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 degrees. So then if we go back here, we can obviously get theta 2 by just taking 90 minus theta 1, because they're going to, or wait, yeah, that would work. It's going to be the complement to that, because it's the other interior angle of the triangle. So from there, it should be fairly easy. I'm never going to give you that kind of analytical geometry problem on a quiz or a test. It's a great brain picker. It's a great puzzle. That's not what I want to test you on. I'm not testing you on analytical geometry. I'm testing you on your ability to find forces. So that would be a waste of our time. Questions on that?
No.
Okay.
Table 1, if they do, we're going to do the plug-in, find the first tension is 2.
Okay. All right. Awesome.
Divide that by 2.
Then
That is already.
that's, so FT1 equals 2 times that. You multiply it by 2 to find FT1.
Yeah.
This is the lesser force, FT2.
Oh.
The way that I had it set up, this is the smaller of the two forces. Again, it doesn't matter. You're just arbitrarily labeling 1, 1, and 1, 2, and I probably change it every time I do the problem. It doesn't matter. You know that one of them is double the other. Make sure that whatever convention you used in the start is what you use at the end. Yeah, or you end up with, the large force and an even larger force. So, all right.